Hello, this is the Debit Coder here. Today I want to show some risks of using DLLs and perhaps ways to avoid problems. So, doing something a little bit different this time where I've already sort of worked on a quick project. This would have taken quite a while to write out if I were to just do it while I'm talking. So, I'm just going to kind of walk through what I've written here and pose an example of something that might go wrong. So first of all, I have a dependency I'm making called datetime utility. Let's go into the header here. Now, I can either import or export it. I'm going to export it if I'm building a DLL. That's going to happen if I'm building this datetime utility. All this is going to do is store the year, month, day, hour, minute, and second. Now you may notice that I have some stuff commented out. I'm planning on expanding this later. I'm going to have a project depend on this that is also a DLL, and it's going to expect an old version of this, which doesn't have some of these features. Okay. Alright. And the thing that's going to depend on it is going to be called chat room. Let's go to that header. It's not going to be a real chat room. I'm not going to make a whole server. I'm just making a fake thing here, just to show an example of what might go wrong with DLLs. Same thing here with the import or export for the chat room. If we're building the chat room, we'll export it, otherwise we're importing it. Okay, what do we have here? We have a socket we could be connected on. We have a port, it could be some number between 0 and 65,535. And we could have the time that the connection occurred. Alright, and then that's the connection information here. The user has that connection information. And keep in mind that this does include a date time. The date time is going to, in its default constructor, specify by the year, month, day, hour, minute, and second what the current time is. Anyway, so we have the username, we have the connection information with the socket information, and the date time. Okay. And it's got a constructor where you can set these things. Now there's a chat room which takes a user and stuffs it into a vector. You can add a user with its name and its connection information, and you can also access the users by constant reference. That way I can iterate through them. And when I iterate through them, I can get the name, and I can also get the connection information, which includes that date time, which also has accessor methods, so I can print that out. Okay, so finally we have our application that I expect something to go wrong in. So I'm going to say crash.cpp, so I called it. And here, all we really have is we include the date time, we include the chat room, and what we're going to do is we're going to define a outstream iterator so we can use vformat to format the date and time easily using modern C++ functions. We're going to use the datetime utility directly within this application, and it's going to expect a newer version. Eventually it's going to have newer features. Okay. It's also going to make a chat room instance. It's going to add a user to it with some connection information, which is going to include the datetime stuff that this Crash application is going to have access to, which might be a newer version. Okay, and it's going to print out user information like the IP address looks like. I printed out the port, the socket, and the username. So all the users in the chat room get their information dumped inside this main application. Now, currently, if I run this, what I'm going to do is I'm actually going to show what I have in this directory. I made a little build bat file because this is kind of complex to build at this point. So let's cat it, build.bat. So I left some remarks here. I would have done this in an SH file and I would have used # to comment things out, but obviously I have an issue with my git bash environment when I compile things. I want to try and run things. So I'm going to do that inside of the PowerShell, which is being accessed through terminal. Okay. So the first thing I do is I build a shared library, and I'm saying that I'm building the datetime utility. I'm defining that. I'm linking in the datetime utility.cpp, and it's going to be called datetime utility.dll when it's built. Technically, this is more of an SO file, because it actually has information that you would need to build like an import library. And because I'm using G++, I'm able to link against that later on in the build. Okay, next thing I'm building is the chat room DLL. So right now I'm saying we're building the chat room, and it's going to pull from the current directory the datetime utility that I build up here in this step. it's going to link in the chatroom CPP and build chatroom DLL from this CPP file and from the utility that it had, daytime utility. Okay, and finally, we have our actual application we called crash. We load in crash CPP. We also load in the two DLLs, the chatroom DLL, which depends on this, and this itself. We're building an application called crash. So let's run that real quick. DLL.bat. Okay, we're going to do crash. Okay, right now everything's the same version, so it'll work. So what I'm going to show here is, if I change what happens in my datetime utility, datetime utility.h, what I'm going to do in here is I'm going to make it to the day of the week, the day of things time, and I'll even add milliseconds. Now what I want to do here is I want to imagine a case where I'm rebuilding this utility, datetime utility. Good. Okay. So now I have two different versions of this DLL. Well, let's reword that. What I have here is a different version of DLL than I first had. And I have chatroom, which depends on the old version, and crash, which depends on the old version currently. Okay, so the chatroom DLL is going to use the old version, or expect the old version. Based on the time it was compiled, it saw the old version of the header, which had less stuff in it. And it also saw, well, that's all it saw, really. They're both only going to see the headers of the DLLs. So this is going to expect less stuff to be in there, this DLL it's already made. Now when I recompile crash, and only crash, it's going to expect a different size datetime utility class. So let's actually do that. I'm going to do cat build.bat here. Alright. I'm going to build just the crash application now. And keep in mind, I'm linking in chatroom DLL, which specs an old version of the datetime utility, and the current version of the datetime utility, which is different. So let's try and actually run that now. Look at that, it crashed. So obviously it's going to have some undefined behavior, because what it's trying to access is go into here. Okay. Let's word this carefully. So this is expecting the current version of datetime utility, and it's going to use chatroom, which also expects this, but it was compiled with an older version. So I guess what I'm trying to say here is if you depend on any kind of dependency, you need to make sure that the dependency that you have was compiled with the same version of its dependencies that you have. So let me make a little like dependency graph here. I'm going to say something like crash, and a little arrow down here. I'm going to say chat room. Okay, I'll put another little arrow down here. Yeah, I'm going to say datetime utility. And this one, datetime utility. So if you have a situation like this, where you share a common dependency with one of your dependencies, you need to make sure that this one, your dependencies, use the same version of the common dependencies. And for that reason, sometimes it's kind of difficult to be able to plan for that, because sometimes you don't know if there's going to be a common dependency. Like, say you have something like from a standard library, like standard string, right? Maybe the version of standard string that you use is different from the version of standard string that they use. And because of that, it's going to have undefined behavior if you do something like, I don't know, have like get string or something. Say this is inside of the DLL, right? From the DLL. Okay, and then locally, in like your main function, whatever, you call something like this, you know, get string function. Right, and you have a local standard string here. Jeez. When this goes out of scope, it's going to use the destructor that your program knows about, even though it might be different from the destructor that it needs, that the DLL knows about. So what I'm trying to say here, in the way to guard against this, really, is just to make sure that you never have any kind of objects you return from a DLL that you free locally. If you get memory from the DLL, you want to make sure that you free it in the DLL. If you have any objects you get from the DLL, you need to make sure that you free those inside the DLL. That's what you always should do. And you should always link things with the same version of the same compiler, so you're not going to get different like C runtimes. Sometimes if you have like different versions of Microsoft Visual Studio, it'll link against a different Microsoft Visual C runtime .dll at runtime. And if you have a DLL that you load, it might depend on a different version of that runtime. So you'll have two different versions of the runtime loaded. And at some point, if you do something like free library, it might free that runtime, which means the way that it manages the heap and there's actually a private heap inside of your DLL windows in that case. It'll all be freed, and anything you have that's inside of that heap is going to be it's going to be gone. If you try to access it, it's going to be undefined behavior. So I'll try a little list here. So 1, use the same compiler for all dependencies that you control. 2, use the same version of the same compiler for all dependencies that you control. 3, trying to think here. Free or resize any memory and destroy. Actually, I'll keep this on a second bullet point here. So, free resize any memory from the DLL using only functions or methods exposed by the DLL. Okay. 4, destroy any objects created by the DLL within the DLL or using methods or functions exposed by the DLL. Right. See that. So in this case, what you might have is something like the DLL. Whenever you need to allocate memory for something that's going to be used in the DLL, you'll probably have some kind of DLL function called, like, I don't know, your DLL name. Say it's like a date, time, utility, allocate. And maybe you'll have something that's like the same thing but free. You pass it a block of memory, you know, ABI free me. Alright, size t bytes or something. Whatever. Some type, you know, buffer equals this. So, if you grab memory from the DLL and you just called like free on it, that could be a problem because you don't know that it's using malloc inside. It could be using like new with brackets, right? And allocating some new type, right? New char, st bytes. You could be doing that internally. So you don't want to mix these. And you don't know what it's doing internally. And even if you did know what it was doing internally, it might be that at runtime you're linking to a different version of the DLL than you expect. Maybe the user has a different version of it. So that's why you do that. And obviously you wouldn't have to qualify this name completely like this. It could be your datetime object has its own allocator method. And like you have an actual class you're using. So it's like datetime, dt, kind of how I have down here, right? Now, whatever. Maybe it has some kind of allocation function. I don't know why it would. It's a datetime object, but maybe it does. So this is obviously kind of a bad example, but even so, the concept is still valid. Let's see. So if you're using the same compiler, using the same version of the same compiler, you're making sure that you only free things that you get from the DLL using DLL class methods or DLL functions. Let's see. Don't return any objects that you don't own from a DLL. So this goes back to what I was saying in the earlier example. Like if you have a DLL function, maybe it's convenient in your DLL to store a name, right? Like you have something like a standard string, store a name inside one of your class objects or something. You know, class blah. One of your private members is just called like member string name. And maybe you actually have an accessor method, right? You have like something, let's say it's standard string, get name or something. I'd const, and you just return this name inside that. Now, the name object that you return might be compiled, like I was saying earlier, from a different version of that string object. Maybe it isn't even standard string. Maybe it's some kind of custom string that you have in a common dependency. Just something you didn't create yourself, and you're returning that type. Well, the caller of your DLL that gets that string type, whatever it is, or whatever the object type is that you don't own and you didn't create, it might expect a different version of that, and also might cause undefined behavior. Now, obviously, this example I gave for this whole project isn't perfect, just because obviously if you're compiling a different version of the DLL and expecting that with your DLL dependency that you can expect with your current project, it's going to cause potential issues, right? Like, essentially, what's causing the crash here is completely fixable because I could just recompile everything. If I go into chatroom.cp here, what's actually happening is I have, inside my chat room, a vector of user objects, and when I add a user, it's just pushing that user into the vector, right? And part of what it's pushing with that user is connection information that the user expects, but this user information is actually bigger than I expect it to be. So this chat room right here expects the user information to only have like year, month, day, hour, minute, second. But I also added millisecond that I'm not using. I also added whether or not it's daylight savings time. I added the day of the week and the day of the year, which is too big. So inside the vector, I'm pushing more information into the vector than it has room for. So you can imagine the vector is allocating something like number of elements times size of each element, right? Size of a single element equals total size in bytes, right? And what I'm doing here is I'm allocating how many elements I need, but right now it thinks it needs one, let's say it's the first, times size of, and it's going to be the user class. But this user class that it expects has less bytes because it doesn't include the day of week, day of year, milliseconds, and daylight savings time rule, right? So it's not allocating enough space to fit it, and then it's trying to stick that into the memory for the vector, which is going to be overriding who knows what in memory. So that's causing the crash. And obviously we control everything here, so we could just make sure that when we build everything, we're building all of our dependencies in the correct order, and we're, what do I say, linking them together with the same compiler and the same version of the same compiler. So if I just rebuild this using my build.bat, it's going to recompile everything in the order it's needed. So the first thing it's needed by everything is a common dependency. It's my date-time utility, right? And then what's requiring that first is my chat room DLL, right? Okay, well, the chat room DLL needs this to be built, and it gets linked against it. Cool, so we know that this is built first. This is built off of that, and then finally my crash application is built off of this, which is built off of that. And since it's compiled in that order, I know everything's compiled with the same version of the same thing. So I can just run it, crash, and it works, right? No problem now. You know, I hope that was helpful. It's kind of a complex topic to go over, but if you oops, go into crashing. If you pretty much follow this kind of list here, you should be okay. There are some things where things get a little bit more complicated. Like if you have a DLL and you, at least in Windows, there's DLL main that lets you initialize things. If you have any global class objects, it's not guaranteed that the class is going to be in a good state. So, you know, there's things like if you want to have an object inside the class, it's global. You might want to do something like expose a function which initializes the DLL, right? And you can have something where, like, the user who calls the DLL, like say you load the DLL, and then you know, maybe if you're doing it dynamically, you'll have to do something like get function addresses, use, call, DLL, init. Like you made your own function. Maybe it's something like datetime utility init. And at the end, maybe you'll want to do something like expose a function to where they can free all the resources. So call something like datetime utility init, initialize, right? Okay, So you want to expose a function which initializes the DLL, and you probably want to expose one which uninitializes as well. Uninitializes DLL. Okay. Anything else? Okay. Yeah, I think this is pretty comprehensive. There's probably one or two small things that I'm missing, and there's obviously slight differences between Windows and Linux on how these DLLs are loaded and the way it resolves things. Yeah, I think I'm going to leave it at this for now. I might revisit this later if I can think of anything else to add. And actually, I do have an idea of something I want to add for static link libraries. I think I'll say that now, actually, because it'll be quick to say. So if you're linking in some .libs, and in this case, they're going to be static link libraries, and you have common dependencies just like this, what's going to happen if this updates is it's actually going to use, imagine like both of these are libraries, like the state time utility is a library, and the chat room is also a library. In this case, if you just link the chat room in, it's automatically going to have this code in, because that gets compiled in the chat room. So if I link this, it's like a .a file, let's say, or .lib on the Windows. And I link this against that, also as a .lib or .a file. It's going to have all the code of this into here. Now, if I build a crash application and only link in this library, it's automatically going to have code from this. And that's completely fine. I could just only link in this. But if I also link this, it's going to use this new version for crash, and it's also going to use this new version for this. All of the symbols in here from this that it needs are going to be overwritten by the symbols from this, so it's still going to work just fine. Of course, that assumes that you're linking in this library first. So for libraries, the order you link in the libraries matters, because it'll basically take the first library or object file, not object file, but first library that actually resolves the symbol it needs. So if there's two libraries which defines hello world, so let's say that's in like lib1.lib, and you have lib2.lib world, okay? And this function maybe prints out hello world, and this one prints out hello world, like that. It's more like grammatically correct. Anyway, this one's going to be the one that gets called if it's linked in first, right? Because this hello world function exists in both, and it found this symbol in this library first. You can imagine there's like a list of things that we don't know. Every time you define a function by saying like int prototype t1, t2, ... right? Every time you define this, you're basically promising the compiler that the linker will be able to find it somewhere in an object file or a library or an SO file that you're linking against it, or maybe a DLL file if you link against an import library. You're also making a promise to the linker and telling it to add code to load that. Either way, you have a bunch of functions like this. Prototype, prototype2, ... You have all these symbols that you need to find the linker and replace. And now, when you're passing these libraries, you're saying, okay, check this directory for libraries. And then one of the libraries I want to load is called, like, I don't know, some library.lib. Another one's like -l lib1.lib, right? -l lib2.lib. Whatever, . As you link these in, if it can find any of these in some library, it'll use that first. If it can't find it, there's still some left over. Like, say we got rid of this, but we need this one now. It tries to find it in this one. If it can't find it there, it'll find it here. But if it finds it here first, it's no longer going to look here for it, right? It's just going to keep resolving symbols until there's none left. Okay? So, I kind of want to show that in an actual example, and I think I'm going to do that in a different video, because I prepared to make this video using a different example for the crash, where I was essentially going to, well, you'll see it in the other video. I'm just going to stop here. Anyway, if you like the video, please like, comment, and subscribe. If you have any comments or suggestions, definitely really leave those, because there could be something you know that I don't hear, or a better way I could explain this, maybe some things I can add, some things I didn't cover. I would like to make sure I do that. If there's something I don't know that I could be doing wrong, like, absolutely I'd want to know that as well. So feedback definitely matters to me. If it's positive, great, love reading it, it's motivating, and if it's negative, like I'm doing something incorrect, I definitely want to know that so I can improve. Not just for my sake, but for the sake of anybody who's watching these videos. I want to have useful and accurate and easy to access information. Like on this channel, it's going on kind of long here, but on this channel, I'm currently trying to show my nephew how to jump right into programming and expose him to as many concepts as quickly as I can as possible. I don't want to make this, what do I say, so concise that it's missing things that are important for him to know, but I also don't want to get too into the weeds to the point that he'll get stuck on one topic and be confused. Because sometimes you might get, what do I say, stuck on something, confused about it, and you don't want to move on until you feel like you understand it. And it might be something really trivial that you're hardly ever going to use. Anyway, I'm going to leave it at that, for real. I'll catch you all later. Have a nice day.